Okay, so hello guys. So today we are going to continue with chapter 6, data descriptive. So the first lecture for today is going to focus on introduction to data 6.1. So the learning outcomes at the end of this topic, students should be able to. So the first subtopic, which is introduction to data, to identify the discrete and continuous data, identify ungroup and group data, construct and interpret stem and leaf diagrams. And then for 6.2, measure of location or measure of central tendency. So we want to find and interpret the mean, mode, median and quartiles for ungroup data, and to construct and interpret box and whiskers plots for ungroup data. So means that there going to be the introduction for statistics and focusing on the ungrouped data for this lecture only. So these are mathematics marks for 20 students who are taking mid-semester test. So let's say these are the results. So how do we interpret? How do we doing conclusion for this data? How can we talk about these 20 students? Are they performing good or just the average, or maybe maybe we have too much low mark student, or what is the next step after this? Okay, so we need to use a statistic to interpret this data. Statistic is a science that deals with collecting, organizing, summarizing, presenting and analyzing data. So in any field in this world, we need mathematics to collect, organize everything lah, so that we can analyze the data and do the next step of the works. Statistics has a wide range of uses in the field of science, business, industry, economic, medicine, education and agriculture. Without mathematics, we don't know what the history, and we don't know what is the optimum solution to deals. Okay, for example, in the field of science, statistical techniques are used to analyze data that is created from the experiment. In the area of business, marketing surveys are carried out to determine the compatibility of the product with the economics and social demands. And then in the formation of national policy, data from the census is used in economic and social planning. So that's why doing the what we call it last years we do. Yes, it's important because we need to know the data to planning. In the field of education, statistical techniques are used to analyze the progress of students in an examination. Okay, that's why we need our UPS, we need our assignments. But if you are not honest in those tests, then we can't help you. A population. So these are the terms that we need to understand before using the statistic. So a population is a collection of all elements whose characteristics are being studied. Okay, so it's collect all the elements we needed for the field. And parameter. Parameter is a summary measure of a population or sample, such as population means, variance, and so on. Sample. Sample is a set of measurements that constitute part or all of the population. That is, a sample is a subset of population. So we take a sample to represent the population. Variables. A variable is any measured characteristic or attribute that differs from different subjects. For example, if the weight of 30 subjects were measured, then weight will be a variable. Quantitative variables. So we have two variables, which is the quantitative and qualitative. So quantitative variables are measured on interval or ratio scale. Qualitative variables are measured on an ordinal and nominal scale. Categorize the following information into qualitative or quantitative. So quality will be the quality of the characteristic. Quantity will be counting the characteristic. So how about the height and height. So height will be the quantity because we can calculate the height. We can measure the height. Type of footwear, because it's a type, so different type of footwear. We have slipper, we have shoes, we have boots and everything, so it will be qualitative. Age of lecturers, so age of lecturers is just a number, so it will be quantitative. And color of the cars, so it's a qualitative data. A survey was carried out on 20 boys and 25 girls in a college to find out whether they like the subject statistic or not. State the population. So the population is the college. Okay, student in a college. The sample, we just only take 20 boys and 25 girls in the college. So it will be the sample. The variable, okay, the variables are, yes, whether they like the subject or not. So that will be the one we are trying to find out. And type of variable, whether it's qualitative or quantitative. Like or not is subjective. We cannot count it. So it will be qualitative variable. So data, we have two types of data, which is quantitative and qualitative. So for quantitative, it will be discrete data and continuous data. So for discrete, let's say we have the size of shoes. Is there any size of shoe 1.23 size? No. Okay, will be discrete data. How about continuous? Yes, continuous will be the one that we can find in a range. For example, the weight of a student, the height, and then the mass. Okay, the mass we use in experiment. For qualitative data, non-numerical will be any quality. Okay. Discrete and continuous data. So discrete data can only take on certain individuals' values, not every values. But continuous data can take on any value in a certain range. For example, discrete data, the number of students in a class. We don't have 3.5 students. Okay, 3 suku tak ada. Okay, and then the number of cars sold on car dealership. So it will be the discrete data. And then continuous data, we will have the weight of student in a class and the time taken to complete an examination. Okay, example 3. Based on the following statements, determine either the data is discrete data or continuous data. Okay, for A, the time taken to travel from Ipoh to Kuala Lumpur. So it's time, so it will be, yes, continuous data. Second, the number of pens sold by a stationery shop. So we don't have 1.2 pen, right? We only have 1, 2, 3, 4, 5 pens. So it will be discrete data. And then the diameter of 10 spheres. Diameter of 10 spheres. So diameter will be any values. So it will be continuous data. And then the number of customers in a cinema in one day. So because it's a customers, it's a people, we don't have 3 suku people. Okay, will be discrete data. And the weight of newborn babies in a hospital will be the weight. Any weight will be, yeah, discrete data. Continuous data. Sorry. Raw data. So we have raw data. Then we can group the data. So it means that the group data is a group in interval, are categorized into mutually exclusive interval, can be presented in frequency distribution table, histogram, polygon and ogive. So all of this you've learned in high school already. Okay, for ungrouped data are listed as a sequence or in the form of frequency table but without the use of interval. Okay. So this is the example of group data. So we have the height. So the height is being grouped into several groups with the same interval. So we have interval of 5 for each of the group. And then for ungrouped data, we have a number of children with a frequency here. So all data is to be considered as sample unless otherwise stated. Okay, measure in statistics. So now For subtopic 6.2, which is the measure of location, to determine the central value of a set data. So what you've learned in high school is mean, median, and mode. And 6.3, the subtopic 6.3, measure of dispersion, to determine the dispersion of a set data, how spread the data is. So we will find the range, interquartile range, standard deviation, and variance. Stem and leaf plot. So what is stem? What is leaf? Okay, you know what is stem. You've learned biology. So we have the stem, and then how the leaf will fill out the stem. So a stem and leaf diagram is used to present and display frequency of a group of data without losing information on individual observation. We are putting all the raw data into the table form. Okay, each value in a stem and leaf is divided into two portions. So to construct a stem and leaf, we should have a stem. Each core will be split into two parts. The first part, first digit, is called stem. The second part, second digit, is called leaf. So it's not only first digit or second digit only. We might have 3 digits or more than 1 digits in the stem. Okay, it depends on the data. Make sure the data is in ascending order. Advantage, the information on individual observation will not be lost. To construct a stem and leaf diagram for the data below. So we have 12, 13, 21, 27, 33, 34, 35, 37, 40, 40, and 41. So this data is in ascending order. So we don't have to reorder lah. So the stem is the left hand column which contain the 10 digits. Okay. So we have the leaf, the list in the right hand column showing all the 1 digits for each of the 10s, 20s, 30s, and 40s. So we have stem. So we have 1, 2, 3, and 4 because this is the one for 10 digits. And leaf, what is the data we have? We have 13, we have 14, 12. So 2 and 3 will be on the leaf part. And then for 20th, so we have 21 and 27. For 30, we have 33, 34, 35, and 37. So 3, 4, 5, 7 will be on the right side. And 4, we have 40 for 2 times and 41. So it will be 0, 0, 1.